Does anybody have any questions about main effects versus interactions, or you want me to put some of the old slides back up and re-explain anything from those? So if you recall, there were some questions on the, I guess this was the third exam, and a lot of people had trouble with those, where I'd present you with a table of results, so you'd see what the average score was for the participants in every cell, and then you'd have to determine, is this a main, is there a main effect? Is there an interaction? Is there a main effect and an interaction? What are those main effects? So I'm going to have something just like that on the final exam, so you'll need to make sure that you've got that straight, and that you understand how to interpret a set of results like that. Okay. So, does anybody have any questions about those? If those of you who are coming in, make sure you turn in your paper up here. All right, well, nobody wants to go over main effects versus interactions. And remember, the factorial matrix is that grid of the, it'll just be 4. I won't go with more than a 2 by 2 factorial.
So, what's the difference between main effect and interaction?
All right, so with a main effect, you're saying that one or the other of your independent variables, or both if you have 2 main effects, has a significant impact on the dependent variable. Okay? Now with an interaction, what you're saying is that one variable has, one variable has an effect, but the effect that it has depends on the level of the other variable. Okay? So let me go ahead and actually put this up. Okay. Let's actually look at the example on the old test, finally. Exam 3. Where was it? Oh, we have it on here. Oh, yeah. Okay, so let me zoom in a little bit here. So these were the questions off the previous exams, and some people had some trouble with this. So remember, the key thing to look at here is the degree of change. So for this first question here, we have the following results. And so we have level 1 and 2 of one variable and level 1 and 2 of another variable. Right? And so we can see that for this variable along the vertical axis, let's see, there's an increase from 20 to 40, so that's by a factor of 20, and then 40 to 80, that's by a factor of 40, all right? And then here we have an increase of 20 and 40, just like before. So that's all consistent. So you've got 2 main effects, but no interaction there because of the fact that you didn't have a larger change okay, my bad, I'm getting confused here. It's been a long day. This was the one that was 2 main effects and an interaction for this one here, right? Because this increase of 40 was bigger than an increase of 20, right? Now for this one down here, you have an increase of 10 and 10, 20 to 30, 30 to 40, and the same this way. So you've got 2 main effects but no interactions. Right?
Wait, why is there not an interaction?
For this one here?
Yeah.
Because you get the degree of increase is similar across the levels of the other independent variable. Right? So it increases, with this one, it increases by 10 regardless of the level of that variable, and the same goes for the other variable. It's an increase of 10, increase of 10, 10, 10, women, so there's no interaction. It's just
For the first one, because the increase was greater, like it was different, is that why there's no interaction?
yeah. So here you have an increase of 20 and an increase of 40. So if you're looking at, let's say this is let's see, people's level of reaction that they have to a particular drug, right, based on whether they're male or female. So you could say that this drug has kind of a moderate effect on men, that it causes an increase in, say, arousal of 20 points, but it has a big effect on women. So it causes an increase that's twice as big as what we saw in men, an increase of 40 points. Right? And so when you say that the effect is more powerful for one condition than for the other, in regards to the the second variable, then that's going to be an interaction. So you should be able to pick these out and see that when that change isn't consistent across levels, when you have something like 20 versus 40 rather than 10 and 10, then that's an interaction. This is just main effects. Okay. So you should be able to pick those patterns out on the final exam. Okay, so moving on to correlational research. Interpreting a correlation coefficient should be pretty much second nature to you all by now. You should just be able to tell me this, of a list of correlations, what's the strongest, and that type of thing. You should know what it means when you have a positive versus a negative correlation, what those distributions look like. So, of course, positive, as measurements of one variable go up, measurements of the other go up too. Negative, it's just the reverse of that, as measurements of one go up, measurements of the other go down. So, any questions about correlation coefficients?
For the one where you tell which correlation is the strongest, can you give an example of that real quick, like with numbers?
Sure. So, well, let's look back at the old test here. All right. Where was our question? Okay. Yeah. So, which of these correlations shows the weakest relationship? We've got positive 0.23, positive 0.07, negative 0.09, negative 0.99. All right. So. When I'm just asking about the strength of the relationship, you can actually ignore the sign. So the sign doesn't matter, whether it's positive or negative. You just need to look at the number itself. And the closer that number is to 1, the stronger the relationship. Remember, the strongest correlation is a correlation of 1.0. So in this one, what would the correct answer be? What would the weakest relationship be? B, yeah, that's the closest to 0, or the furthest from 1. So the weakest relationship you can have is 0.0. Okay? So remember, you just need to ignore the signs, and then that question will be a lot easier. Okay?
The strongest would be 0.99.
Yeah, the strongest would be 0.99, because that's almost 1. That's going to look essentially like a straight line if you were to plot those points out. Right. And what else do we have here? Be familiar with things that can cause problems with correlational designs and what these problems will look like. So, what was a curvilinear relationship? Yeah, it's a relationship between two variables that isn't just a straight line. So the example that we gave was the relationship between arousal and performance. When people have low levels of arousal, they don't perform all that well. When they have moderate levels of arousal, they perform pretty well. But when they have very high levels of arousal and they're stressed out, their performance goes back down. And so it's a curved line. It's not a straight line between those points. And so if you just tried to use a bivariate correlation to look at that, it would look like there was no correlation between those things. You wouldn't be able to find that. And then the other problem was the problem of restricted range. Bless you. So, with restricted range, I mentioned, well, I'll go ahead and put the slide up for this one because the illustration really just makes it totally clear. I hope. that if you're looking at the relationship between SAT scores and GPA, well, there might be a positive correlation between those. So you can see as one goes up, the other goes up. Now it's just, it's a relatively strong relationship, but you only see this relationship if you're looking across the entire range of SAT scores. And if you restrict the range and only look at students with SAT scores of 1200 to 1600, then you would see something like this. And this would look like a correlation of about 0. And so that's going to be a big problem for these studies, because that's going to lead you to conclude that there's no relationship when there really is. You just didn't have the range of data necessary to find that relationship. And let's see. Why is regression useful? So what's the main use of regression? Yep, it's all about prediction. Remember, regression is when you know the correlation, you know a bit about the relationship between these two things, and then you make a regression equation, and that lets you plug in values of one variable and then predict the value of another variable based on existing knowledge. Aaron and colleagues' studies of the relationships between TV viewing preferences and aggressiveness. So, do you have a question?
Like for the regression thing, like on the test, I know that you wouldn't put a question up there as simple as why is it useful to make predictions. So my question is, how would you like what are we gonna do? Like, you know what I'm saying? I feel like it's never that simple for you. So I was wondering, I'm not trying to be funny or anything, but I just want to know like what form would you put that in, because I feel like with the study guide, I always say, oh yeah, regression is useful to make predictions, but then I get the test and it's nowhere near that simple of an answer.
Okay, well, let's look at the old test. See what this looked like. I know I had a question like this on the old test. Let's see, to predict college success from a combination of high school grades, weighted letters of recommendation, and SAT scores, and admissions department would probably use what procedure? And so for that one, the correct answer was multiple regression, because that's just regression using multiple predictors. So you have to know that regression is used to predict for that question. And then you also have to know that multiple regression is just prediction using multiple different types of items. So instead of just trying to predict college success from high school grades, you're looking at high school grades, letters of recommendation, and SAT scores, and putting those all into one big multiple regression equation. And so that's how that was formatted on the previous test anyway, as an example. No problem. Let's see here.